Now, let us take an example. Say this is an example where I have directly drawn the entire network so that we can find the critical path from this entire network. Now see, when your question will come in the university, you will get nearly 3 to 4 marks in drawing this diagram. So obviously you will get the entire data for drawing this diagram. That means 1, 2 will be given as 6, 1, 3 will be given as 7, like that. Similarly, it may come that A activity is 6, B activity is 7, C activity is 8, like that. And as I have told that there is a concept of successor and predecessor. Here what is that? Say D has a predecessor A. Similarly, A has a successor D. Similarly, we can say A has a successor D and D. Similarly, in other words, just the reverse, D and E has a predecessor A. So just like this, the entire particular data will be given in the university question. Now, somehow if the question comes, including CPM and later on we will do the part, so the entire question will carry nearly 15 marks. So keep it in mind. So if you can rather complete the diagram, if you can find the critical path, and finally if you go with the part, you will get the whole marks, that is the 15 marks. There is step marking also, so no need to worry about that. It's very simple. Now this is the diagram, just go through it. A is 6, that is 1, 2 is the activity A, 6, 1, 3, activity B 7, 1, 4, activity C is 8. Similarly 2, 5, 2, 7, then 3, 8, like that the entire data is given and I have drawn the network. But here you see that from 5 to 7 I have given as D1 within bracket 0. Now what is this D1? Now this D1 is the concept of dummy activity. This is the concept of dummy activity. Now this dummy activity, as the numbers will increase, if you go for more dummy, then starting with 1, you can go on with numbering, that is the 2, 3, like that. But never give only D. If you give D, that will basically mean that that is the activity. So that is an activity, but it is a dummy activity. That's why you have to give it as D1 within bracket 0. That means the entire resource for that dummy activity is 0. Now let's start calculating the earliest start time and the latest finish time as we have told earlier. For that, we have to draw rectangular boxes in every particular nodes. In every particular nodes, just draw the rectangular boxes, just like what I am doing. Same. Because if you go through the book, you will get confused. So to come out of the confusion, we will do in this way, so that we do not get confused and our answers will be perfectly correct. So for every nodes, we will draw these boxes. And what these boxes means, you see that there are 2 halves in every node regarding one rectangular box. So what does that mean? Now, say this is the box. The right hand side of the box will be LFT. You have to calculate latest finish time in the right hand side, latest finish time. And in the left hand side of the box, we have to calculate the earliest start time. We have to calculate earliest start time, EST, just like what we have told in the earlier in this video. So these 2 things we have to calculate. One is earliest start time in the left hand side, let us finish time in the right hand side. So let us do step by step. So step 1, we have to calculate earliest start time. That is this one. Now, though it is known as earliest start time, but the meaning is little bit different. Just you can say the reverse. While I am talking, that it is just the reverse, because here you have to calculate in all these left hand side of these rectangular boxes the maximum number of time or maximum activity to finish that particular network. That we have to find. Now how we will find that? Let's see. Be very careful when we will calculate this particular EST, earliest start time. Now see, before node 1 there is no other activities. So when it will start? Obviously in the day 0. So here we will start with day 0, because previously there is no activity, no A, no B, nothing. So the starting time will be the day 0. Tomorrow I am going to start, so that will be the day 0. Now let us go to the next node, that is node 2. Now in node 2 you have to see how many arrowheads are entering into that node. How many arrowheads are entering into that node. So how many arrowheads are there? Only one. So 0 plus 6 is 6. Next 3. How many arrowheads are there? Now here also 1. So 0 plus 7 is 7. How many arrowheads are there in 4? Again 1. So 0 plus 8 is 8. Now let's go to 5. How many arrowheads are there? Only one arrowhead. From where it is coming? Node 2. So in node 2 what is the earliest start time? 6. 6 plus 18 will be, here I have not drawn the this thing. So let us draw this. I am sorry. So here it will be 6 plus 18 will be 24. 6 plus 18 will be 24. So we have done here 5. Next 6. In 6 how many arrowheads are there? See, there are 2 arrowheads. Now here comes the problem. Now what is that problem? We have to consider both the arrowheads, which is coming from 4, which is coming from 3. Again I am saying both the arrowheads. See, there are 2 arrowheads. So one is coming from 3, another is coming from 4. So if we take it as 3, then what will be the EST? 8 plus 7, it will be 15. 8 plus 7, it will be 15. But if we consider 4, it will be 8 plus 2, 10. So what is the maximum? Maximum is 8 plus 7, that is 15. So 10 is not maximum. So within this 2, if we calculate, we have to take the maximum. So maximum is 8 plus 7, that is 15. Next, let us go to 7. Again here you see that 2 arrowheads are coming. One is from 2, another is a dummy which is rather entering into the 7 from 5. So that also you have to consider, as it is the dummy activity. So 6 plus 20 is 26. 24 plus 0 is 24. So which one is the maximum? So obviously 26 is the maximum. So we will write 26 here. Here 6 plus 20, 26. 24 plus 0, 24. So 24 and 26, maximum is 26. Now let's come to 8. In 8 there are 3 arrowheads. One is coming from 7, another is coming from 3, another is coming from 6. So we have to calculate 3 of them. So let us start with 3. That is coming from the node 3. So 7 plus 9, 16. Then 6. 15 plus 14, 29. 26 plus 7, 33. So which one is the maximum? The maximum is 26 plus 7, that is 33. Because here it is 15 plus 14, 29. Here it is 7 plus 9 is 16. So 33 is the maximum. So write down 33. So till node 8 we have calculated the earliest start time. Next, here you see the last node is 9 and here only one arrowhead is coming from 8. So 33 plus 10 will be simple as 43. Now what is this called? It is known as forward pass calculation. It is known as forward pass calculation. Again I am repeating, forward pass calculation. Now we have done all the EST, earliest start time. We have calculated all the earliest start time. Now let us calculate the latest finish time. Let us calculate the latest finish time. Now you see that earliest start time we have started with the node 1, starting node. But latest finish time will start from the end node. The latest finish time will start from the end node. That is the last node, 9. Now, here again you have to see that after node 9, is there any activity? See that there is no other activity after 9. That means the latest finish time in which we can complete the network is same as the earliest start time, that is the 43. So just write down 43 here, nothing else. It's very simple because there is no other activities after that. So maximum time, that is the latest finish time, it can complete, it can come to the node 9 is 43. Now, we have to use the backward pass calculation. Here we have used the forward pass calculation. Now we will use the backward pass calculation. That means from node 8 we have to come backwards. Now, when we are using the forward pass calculation, we are using the arrowheads. These are the arrowheads. Now when we will go with the backward pass calculation, we will go with the arrow tails. These are the arrow tails. We have to consider all the arrow tails. Excuse me. So let us come to 8. How many arrowheads are coming to 8? Only one arrowhead. So no problem. Here we have to subtract from 43. So 43 minus 10, 33. Only one arrowhead is there, so no problem. So 43 minus 10, 33. Now from 8, let us go to 7. How many arrow tails are here? Only one. So again no problem. 33 minus 7, how much? 26. Now after that 6, how many arrow tails? Only one arrow tail. Again no problem. 33 minus 14, how much? It is 19. But if we go to 3, then there will be 2 arrow tails. But in 4, there is only one arrow tail. So let us calculate 4. So 19 minus 2, it will be how much? 17. Now in 3, how many arrow tails are there? 2 arrow tails are there. Simple, 2 arrow tails. So one is coming from 6, another is coming from 8. So 33 minus 9 will be how much? 33 minus 9, 24. But we have to calculate both of them. Another is coming from 6, that is 19 minus 8 is 11. Here we have to take the minimum of both. Here we have to take minimum of both. That is 33 minus 9 is 24. 19 minus 8 is 11. So which one is the minimum? 11 is the minimum. So keep it in mind. Here it is maximum, forward pass. Backward pass, minimum. Forward pass, maximum. Backward pass, minimum. Next, let us come to say 5. Now in 5, how many arrow tails are there? Only the dummy arrow tail. So 26 minus 0 is 26. In 2, how many arrow tails? Again 2. One is coming from 7, another is coming from 5. So let us calculate both of them. 26 minus 20 is 6. 26 minus 18 is 8. So which one is the minimum? 6. So we are writing 6. Now only left is 1. So again, how many arrow tails are there? 3. This one, this and this. So 6 minus 6 is 0. 11 minus 7 is 4, 17 minus 8 is 9. So which one we will take? Obviously the minimum, 0. So here we have already calculated the earliest start time and the latest finish time. Next what? Next we have to double tick those particular boxes where EST will be equals to LFT. We have to double tick those particular boxes where EST will be equals to LFT. So which one of them are same, EST and LFT? Say this one, then this one, or then this one, then let's start with this one, and finally this one. Now see, what are the nodes? 1, 2, 7, 8 and obviously 9, where EST is equals to LFT. Now join all these nodes with another line. So 1, 2, then 2, 7, then 7, 8, then 8, 9. Now this 1, 2, 7, 8, 9 is the critical path. So what we will write? Critical path, that is the shortest path, is equals to 1, 2, 1, 2, 2, 7, 2, 7, 7, 8, 8, 9. Now 1, 2 activity time is how much? 6. Then 2, 7 activity time is how much? 20. 7, 8 activity time is how much? 7. 8, 9 is 10. Now add all of them, you will get 43. Add all of them, you will get 43. 6 plus 20, 26. 26 plus 7, 33. 33 plus 10 is equals to 43. So you see, in this particular network, only one critical path exists. But it is not true that every network will have only one critical path. There may be multiple critical paths. So in this particular video lecture, I think you have already understood how to find the critical path. In the next video lecture, we will do one assignment. That means I will deliver you one assignment. You have to do it by your own. And after that, we will start with